Hello everyone, welcome to this talk and thank you for making the time today. My name is Shyam Krishnamurthy and I'm the General Manager for AWS IoT Device Software, and I'm accompanied by Usman Anwar, who's a Principal Product Manager in the AWS IoT team. Today we're here to talk to you about AWS IoT SiteWise Edge, a new feature of AWS IoT SiteWise that helps customers in industrial and manufacturing industries really take advantage of edge and cloud computing to achieve industrial automation and industrial IoT outcomes. Today, we're going to talk about the why, the what, and the how of AWS IoT SiteWise Edge. We'll talk about the rise of industrial IoT and what customers are doing with it, what we're seeing across various industries. And then we'll talk about AWS IoT SiteWise itself, the service that we launched earlier, and how it's really solving a lot of problems for industrial customers trying to achieve and improve business outcomes with IoT. And we'll then talk to you about some of the challenges that customers still face and we've heard feedback from that brought us to launching this new feature, AWS IoT SiteWise Edge. And then I'll hand over to Usman, who'll help walk us through the what and the how. What does AWS IoT SiteWise Edge have? What are the features? How do you use it? How do you get started? And walk us through a customer example as well. So you've probably heard this term, industrial IoT, and you've heard, I'm sure, about how it's transforming a variety of industries, manufacturing being the prime example, but it could be mining, it could be renewables, it could be oil and gas. In all of these fields, customers are using industrial automation, and now with data and the power of the internet and the cloud, really entering this phase that we call now Industry 4.0, where we're able to take the power of data collected from plants and use the power of the analytics on the cloud together to really improve a lot of processes. So what does that mean? What does improving processes mean? Well, we're seeing customers in industrial IoT, imagine a factory that is building car doors, right? They're using industrial IoT to improve the quality, checking whether parts are achieving the right measurements. Do they have the right paint on, for example? Many different use cases where quality is being improved by automatically collecting data on that, analyzing it, and making faster decisions. We're also seeing industrial IoT being used in predictive maintenance. So when you look at equipment, when you are able to predict that an equipment is about to fail before it does, you save a lot of time in fixing that, and you save money for the company as well by being able to fix that before it breaks down without work stoppage. You see industrial IoT being used to ensure employee safety. With heavy industries, especially in factories or in mining, there's a lot of different areas that could be potential dangers for employees. And we can use IoT technologies, a combination of devices, sensors, and computing to really identify danger zones and prevent errors before they happen and really protect workers and employees in all your companies. And lastly, all of this comes together in achieving business outcomes, right? The business outcomes are getting more innovation for your company, raising your savings, increasing your savings in many billions sometimes, and really putting all of that effectiveness, on the factory floor, what's sometimes measured as the OEE. How do you have the maximum productivity across all of your systems in the factory? And industrial IoT is being used for that as well. So what does that mean? How do you use industrial IoT to achieve the outcomes that you really want? And we start with data, right? The factories that we have, the plants that you have, the mines that we have, all of them already have a lot of environmental data, a lot of equipment data, a lot of additional data that is context. For example, who's on shift, how many people do you have, what are the work orders coming in? And we start with that data, but we need to understand that data, which means you need to label it, organize it, and enrich it with that context. Is that temperature information? Is that heat? Is that employee shift data? And so you need to be able to take all of these data streams and tag it and really understand it. And then that information leads you to insights when you analyze it and when you make inferences off of that. And that insight leads to business decisions, right? So it's a very standard flow, but every one of those flows requires effort, right? For companies that are really trying to solve big problems with industrial IoT, big savings. You have to build systems that go through each of these phases. And that's why we launched AWS IoT SiteWise earlier. What IoT SiteWise offers you is the ability to ingest equipment data from the plant floor and then take that data, label it. So we have asset models where you can attach different data types, transformations, filters to the specific data streams that you're getting from the plant floor or from other systems in the factory. And you're able to then analyze it. You store it in a system, you pull it out for analytics with IoT services or any other AWS service, and really be able to make meaningful decisions off of that. We also offer inbuilt visualization in the form of AWS IoT SiteWise Monitor. And all of these work together. The Volkswagen Group is actually using the AWS IoT services, including AWS IoT SiteWise, to improve and digitize their plants. And over 100 of them will actually incorporate a number of industrial IoT techniques to improve their productivity, safety, and quality of their plants. And when we talk to them, they see that they're able to use this, and over the course of a few years, they're expecting billions in savings. And it's one of the largest Industry 4.0 projects right now in play, called the Digital Production Platform. So really happy to have that partnership and really validate that AWS IoT SiteWise is able to help our customers really get these benefits. So let's now talk about a smaller use case, right? Because if you think about somebody like Volkswagen and a plant that's building a car, there's going to be thousands of sensors on it, thousands of equipment data. And what I want to do is set up the use case of something simpler so you can understand what leads us to build AWS IoT SiteWise Edge. So let's zoom into a single factory, and we'll go back a little bit to our childhood and talk about building a toy airplane. And it has just 4 parts, maybe a main body and 2 wings and a tail wing. And let's talk about how, in a much smaller example, if we had a factory that was building our toy airplane from our childhood, it can actually apply Industry 4.0, industrial IoT techniques to really make this factory much more effective. Imagine this factory has 4 serialized workstations or work cells in the plant. So the first cell has a machine that takes those 4 parts together and assembles it. The second one has a machine that paints the logo on it. The third station has a drying station, which does a heat dry both for the logo and for the glue that puts all those parts together. And the last station is a testing station, which does a stress test as well as looks at the paint quality before it's packed off and shipped to kids all over the world, right? So when we think about this example of just simple 4 stations, you can actually apply all of these techniques we just talked about and all of these benefits that we want in terms of industrial IoT to these. Let's take some examples. So imagine that the assembly station is a fairly complicated machine that's putting things together, and it can break down, and you can actually use vibration sensing or other techniques to actually look at whether the patterns are indicating imminent failure and try to do predictive maintenance for that equipment, right? So you gather machine health data, make some inferences off of that data, and determine if this is going to fail and trigger an alert for the technician to come and fix it before it does. So that sounds great, but we've got some interesting challenges here that we want to think about. That data, do I want to actually analyze that data locally, or do I want to send that to the cloud? If you think about vibration sensors, for example, as a technique to solve this, if I'm collecting half a kilobyte every millisecond, and I want to send that to the cloud, within a day I have many gigabytes of data. And a lot of that data might be actually just sensor noise, calibration issues, or little spikes that actually don't have a lot of meaning until you've sort of smoothed it, you've done some filtering, and so on and so forth. So you have to think about, okay, what part of that processing do I want to do in the factory itself locally? How much do I want to send that data to the cloud? What bandwidth do I have, and what are my cost savings depending on how I distribute that workload? You think about the drying station. Maybe there's a lot of heat coming out, and employees need to keep at least a 2-foot distance from the key parts of that device. Can I use industrial IoT techniques to improve employee safety? Proximity sensors, infrared sensors. So using other techniques, cameras as well, to both give localized warnings saying, hey, you're too close, maybe you want to move away, maybe automatically shut down that equipment, and maybe even make longer term decisions saying, okay, maybe my actual placement of equipment in the factory can be optimized based on how employees are walking around and if maybe they're getting too close to some of the equipment. So if we want to do that, again, which safety decisions do I have to do locally and have to continue doing even when my network may be unreliable? And which decisions can I send to the AWS IoT SiteWise service and other analytics services in AWS and make those decisions there? Let's take another example again. Let's go further down the chain and look at this device that's testing these. And that device, for example, may be having a camera that is looking at the paint and doing some machine learning techniques to find out if the paint was applied correctly or not. And again, camera data can be quite bandwidth intensive, but also this is a place where machine learning has been established as a very useful way to really get good productivity improvements, because it can actually look at patterns and identify if the paint has been applied correctly. But if I want to use machine learning on camera data to identify quality issues, then I have to have training done on my machine learning, and then I have to do inference based on those training models. Do I want to do the inference locally or in the cloud? Do I want to do the training locally or in the cloud? And in each of these, you'll see that some of the processing, for example, in this case, you want to do the inference locally so that you can continue having the factory be effective in spite of unreliable connectivity. But you want to do the training in the cloud where you've got all the computing power to really refine that model over time. Lastly, you put it all together into building the entire system, and you've got a process engineer saying, am I producing the number of units that my order needs today? Do I have the right number of people staffing the station? Do I have the right parts? And is there a bottleneck between my stations? So my overall equipment effectiveness, or OEE, that they measure, you want process engineers to be able to use, again, industrial IoT, measure the throughput of each of these devices and make optimizations. Do you want to do those optimizations locally? Probably, but you also want business decision makers maybe comparing data across multiple factories and saying, how do I actually take best practices because one factory is having very good throughput, and apply that to other factories? And that the cloud is a great place to aggregate all of that data. So when you look back at all these examples, what you see is really that the best solution is a cooperative situation where the edge computing nodes and your cloud computing nodes actually cooperate to split the right workloads. If you think about data processing, you can reduce your costs by filtering, removing noise, and aggregating high volume data locally and sending the rest of that to the cloud for additional processing. If you think about monitoring for that process engineer, they want to do factory specific monitoring locally so you can make real-time decisions day to day, and in whether or not you have the connectivity and the bandwidth, you can make those decisions. And then you want to send a lot of that data to the cloud so that decision makers who are at a cross-factory level can make certain decisions of optimizing as well. Maybe they shift some of the orders to a different factory, so you're continuing to be maximizing your throughput. And lastly, there are situations like employee safety where you have to continue operating even if you're completely disconnected. So having those disconnected operations is super useful. And so you put all of that together back in this example that we talked about, is you can see every one of these phases, there's useful computing and useful value that you can get for your company by applying industrial IoT computing at the edge. And there's other useful scenarios where you apply that industrial computing in the cloud. So we heard that from customers, whether it was our customer working with Volkswagen or other customers using AWS SiteWise. And that's why we've been hard at work, and we're very excited to introduce to you AWS IoT SiteWise Edge. And what AWS IoT SiteWise Edge does is really takes that service that we already have that gives you all of those pieces of converting the data into information and then into insights so you can make those business decisions, and enables you to do all of those pieces in the cloud or at the edge depending on your use case. So if you remember this picture from before where you collect all of that data and then you tag it, label it, filter, aggregate, and with asset models, and then you're also monitoring it with dashboards and so on, what AWS IoT SiteWise Edge does is, in the local gateway that was previously just sending all of that data to the cloud, brings the same asset models, brings the same APIs, brings the same capabilities, And one of the things our customer said is we don't want to think about it as two different systems, right? So we want this to be a cooperative system. And that's what we're doing here, is bringing all of the capabilities of AWS IoT SiteWise to the edge. And you can then use the processing you need locally and the processing you need in the cloud using the same semantics and the same capabilities. So very excited about that. And I want to hand over to Usman, who's going to give you a deep dive into how AWS IoT SiteWise Edge works and all the capabilities you can use. Thank you.
Thank you, Sham. Hi, everyone. I'm Usman, and we're product manager for AWS IoT team focused on industrial IoT. Let's dive right into the details of SiteWise Edge. SiteWise Edge provides you with three sets of capabilities. First, it enables you to collect and process data on premises in the SiteWise gateway. Specifically, you can compute metrics and transforms that you've defined in your asset models entirely on the gateway. Second, it enables you to monitor equipment data and processes on the factory floor through your own line of business applications or through the SiteWise Monitor dashboard that SiteWise Edge brings to your gateway. Third, it provides tools to help you easily manage your gateways in a disconnected scenario, such as understanding the health of the gateway device or debugging the connection between your data sources and the gateway and between the gateway and the cloud. Before we can dive into the SiteWise Edge software, we must pick a gateway device to run the software on. Today, industrial customers are in different stages of their transformation journey. Some are exploring use cases, others are looking to scale their existing pilots from a few sites to production across all their sites. We have made SiteWise Edge software work with a range of device form factors to accommodate this diversity of use cases and ensure choice for customers. You can start with a Linux industrial computer or a Snow family device such as a Snowball Edge, going all the way to an AWS Outpost instance for your largest workloads. SiteWise Edge runs on Greengrass. So technically, you can use any Greengrass device to run SiteWise Edge. However, we recommend you choose at least an industrial computer with a 4-core processor and 16 GB RAM with 256 GB of storage. SiteWise Edge delivers capabilities to your gateway through packs. The data collection pack offers support for reading data using common industrial protocols and routing it to various cloud destinations. In addition to the OPC UA protocol, which is already supported in the gateway, you can now collect data from Modbus and Ethernet IP sources. In addition to sending data to SiteWise Edge, you can also now programmatically export data from the gateway to other AWS services such as Amazon S3 and TimeStream. You can configure multiple sources and destinations depending on the resources on the gateway. For example, you could use the same gateway to read data from an OPC UA source, from an Ethernet IP source, and a Modbus source, and then send them to two different destinations. This allows you to develop flexible industrial IoT architectures around the SiteWise service. The pack includes mechanisms to collect and transport data reliably in intermittent connectivity environments, which are common for factories. For example, if the connection to the cloud goes down, the gateway can store the data from multiple sources and then transfer it to the cloud when the connection comes back online. The SiteWise Cloud service now automatically processes this late arriving data to backfill your transforms and metrics defined in the cloud. The data that is collected can be processed in real time with the data processing pack. Equipment data is often unstructured and lacks the context necessary for the data to be understandable to end users and to applications. Additionally, raw data by itself is often not enough for industrial use cases. It needs to be further processed into metrics that can then be used to drive business decisions. SiteWise addresses these challenges through asset models. Using an asset model, you can group data streams to virtually represent your equipment. You can label them with standard identifiers and assign consistent units. You can then transform these data streams. For example, you can convert a Fahrenheit data stream coming out of an evaporator asset into a Celsius data stream, or many equipment output their status as numerical codes. You can convert these codes into meaningful states such as running, idle, stopped, or faulted, which you can then use in metrics such as OE, or overall equipment efficiency. With the data processing pack, you can do all of this entirely at the edge in your gateway. And you do it not simply to move your cloud workloads to the edge, but to address concerns specific to on-premises use cases and constraints. For example, you may be computing metrics in the cloud to understand trends across multiple sites over a period of time. Many customers tell us that while that is great, like before they can send the data to the cloud, they often need to filter it down because the equipment often sends data in much higher frequencies than what they really need to compute these cross-site metrics. For example, you could have an equipment sending 10 data points per second, whereas you need only one data. So using metrics and asset models, you can aggregate this data at the edge and then emit only one data point, which is the average of all the data points collected in a minute. And customers can use this to reduce the frequency of the data, to optimize the use of bandwidth out of remote sites, such as wind farms and mines. Often, customers have multiple applications that have to share the internet connection. So if you are sending data that you don't really need for analytics through that connection, you might be doing that at the cost of other applications. So by filtering the data, you can better utilize the bandwidth that you have at your sites. Another edge-specific use case where the industrial pack is helpful is production line monitoring. Many customers today are building capabilities to monitor production lines locally in real time so they can react quickly to equipment issues or quality issues as they arise. These capabilities must work when the internet connection is down, which is a fair occurrence in many industrial sites. Let's look at how you can enable these capabilities on your gateway. You can enable the data processing pack through the SiteWise console. You simply go into the gateway creation flow, or you can edit your existing gateway, where you would now see a setting to enable edge capabilities. The data collection capabilities are enabled by default for all gateways, but data processing capabilities require you to opt into them. Once you opt into them, you can then go and deploy the connectors required to process the data at the edge. SiteWise software is deployed on Greengrass cores as Greengrass connectors. Once you opt into the data processing pack, SiteWise Edge will link up all these connectors together to create a complete data processing pipeline within your gateway. This processing pipeline can read data from multiple sources. It can process data using asset models, compute metrics, and transforms, and then it can publish this data reliably to the SiteWise cloud service. After configuring the gateway, you can configure asset models for the edge. By default, asset model properties are collected and computed in the cloud. These properties are your measurements, transforms, and metrics defined in your asset models. But now you can choose to keep the measurements at the edge, and you can choose to compute the metrics and transforms at the edge and just send the final result to the cloud for long-term storage and additional analysis. You can also mix and match computing some properties at the edge and some in the cloud. SiteWise Edge automatically syncs asset model definitions and your edge configurations with your gateways, so you don't have to worry about manually doing so and tracking the changes. So let's see how we can configure an asset model optimally for a real-world use case. So similar to making a paper plane, to making a toy plane that Sham described, many industries involve a quality checking step for their products. And often this quality checking step can be in form of weighing the final product that's coming out off of the production line. Operators use carefully calibrated equipment to get these weight readings in real time. And then they use this information to either approve the unit for shipping to the customer or rejecting it or reprocessing it. This use case lends itself really well to edge data processing. The weighing equipment usually does not measure the weight of the product directly. Instead, it uses electrical signals that are coming from load cells that need to be processed into weight. With an asset model, you can transform the measurement coming out from load cells, which is often in milliamps, into weight in grams that can then be displayed to the operator. And then you can also use, and then you can compute metrics such as average weight for some additional insights. Let's see what configuration makes sense for a simple weighing machine that we have modeled in SiteWise. The load cell measurement is not directly useful to the end processor or the process analyst. It is just a signal that needs to be processed further. There may not be, depending on the use case and your requirements, there may not be enough value in storing this data long term in the cloud. So we can choose to keep this one at the edge. The weight is the most critical to keep the quality check process running smoothly. It must be computed and displayed to the user in real time, lowest possible latency, and the display must not depend on anything else external to the system, such as an internet connection to the cloud. So it may be best to compute the weight transform at the edge for your quality monitoring applications. The average of weights is interesting because the average of weights across products, production lines, shifts, sites, quarters can provide useful insights into the longer term patterns of quality across the entire operation. This analysis is likely to be performed offline by analysts in corporate offices, not on the factory floors. It may involve processing a large volume of data collected from multiple sites over a long period of time. So it may be most suitable to compute this metric in the cloud and store it there long term. Let's take a look at some of the things that SiteWise Edge does under the hood to deliver on your configuration while ensuring performance. SiteWise Edge uses sophisticated data processing to normalize your data into a common format to streamline the processing of the data through the pipeline. Since most of the data is time series, the streams are stored in a local time series database to support concurrent reads by multiple applications on the factory floor, and also ensure integrity of the data. To ensure real-time performance, SiteWise Edge triggers processing of the data on arrival of the data. So every time a data point is received by the gateway, the Edge software checks the asset models and the Edge configs that apply to it, and then it queues the data for processing immediately. The software uses Greengrass Stream Manager feature to transfer the data between these different reading, queuing, and processing and polling processes. This decouples the performance of one process from impacting the other, ensuring optimal performance of the overall system. For example, a slowdown in metrics computation would not cause a slowdown in collection of equipment data. Once the data is processed, you can put it in the hands of decision makers through applications. With SiteWise Edge, you have two options to do that. You can either read the data into your custom line of business applications using the same APIs, SiteWise data plane APIs that you use in the cloud, or you can use locally hosted SiteWise monitor dashboards. To read data into custom apps, you can use the same data plane APIs available in the cloud today. In an edge environment, these APIs query the data directly from the gateway over the local network. Since security is our top priority, all API calls are secured through SigB4 credentials. And when it comes to apps, many customers are excited about using using SiteWise data in ML models that they have trained to detect anomalies, to predict equipment failures, to detect hazardous conditions, so on and so forth. They can deploy those models via Greengrass on the same core that the SiteWise connectors are running on. And then they can call into SiteWise to get the data using these APIs. So this helps you unify your edge compute applications on the Greengrass platform and use SiteWise Edge. Another option to monitor data is to simply use the SiteWise dashboards. Many customers that we talk to start their transformation journey by making insights widely available on the factory floor. This is often done through dashboards. If you enable the data processing pack, you can view dashboards locally that you've created in the cloud, and then which read data directly from the gateway. If your internet connection goes down, these dashboards are completely uninterrupted. You won't even notice that something has happened. Today, you author these dashboards in the monitor portals in the cloud, and then SiteWise's deployment pipeline takes those dashboards and make them available on the gateway, from where they are served to local computers through a web server that is hosted on the gateway as well. So now you know how you can collect and process data through SiteWise Edge and the gateway, and how you can monitor it to drive business decisions and process efficiencies. However, many customers tell us that the challenge they face with industrial IoT is not just achieving this functionality and enabling apps. It is also the sustainability and scalability of their solutions from a management and a support perspective. SiteWise provides a local application that you can download on a Windows PC to monitor and debug your gateways that might have gone offline for any issue completely locally. You can use this app to access local resources on the gateway. For example, you can find out what are all the dashboards that are available. You can find the links and then share those links with your colleagues. You can view gateway health. For example, you can check if you are running out of disk space or if you're over consuming CPU, which may indicate a need to upgrade to a more resourceful device. You can diagnose the connection between the data sources and the gateways by checking if you're getting data from the source for your specific asset models. You can also take corrective actions such as restarting the software or forcing the gateway to sync with the latest asset model definitions in the cloud. We are excited to see customers take their first step with industrial IoT with IoT SiteWise. Rearic Pacific is one such customer. Rearic Pacific has been manufacturing plastic products for several decades. These products help us manage waste and reliably transport goods. With SiteWise, Rearic is developing capabilities to manage efficiency across multiple sites. SiteWise Edge plays a key role in ensuring that these capabilities are available regardless of an internet connection. So plastic products such as recycling bins and material handling containers are manufactured in multiple steps at distinct workstations, very similar to our toy airplane example earlier. For example, they are molded. The main container is molded at one station. The covers are stamped and shaped in another station. The whole product is assembled in yet another station, and then it can move to further stations such as for labeling and for packaging, etc. And then finally for a quality check. Rearig's initial goal is to reduce the buildup of inventory and work in progress material that can arise from bottlenecks in this end-to-end process. These bottlenecks result from slowdown of operations at each of these individual stations. Often these slowdowns can occur due to equipment issues. By monitoring equipment at each of these stations, Rearig can quickly detect and resolve any bottlenecks. As a result, they can dramatically reduce or even eliminate the cost of handling unintended inventory buildup on site. With SiteWise Edge, Rearic Pacific can enable several use cases. They can monitor utilization of their assets locally in real time and root cause issues by sifting through the raw data, uninterrupted by any cloud connectivity issues. By collecting this data in the cloud, they can understand longer term trends. For example, they can understand what type of stations contribute most to the bottlenecks, how much time it takes to resolve issues for different stations, for different sites, which make and model of equipment works better than the other for their specific production process. And they can use this information to drive major process planning and business planning decisions. We can't wait to enable more customers to kickstart and scale industrial IoT on the factory floor with SiteWise Edge. As a recap, you can use SiteWise Edge to collect and process data locally. You can take advantage of our cooperative edge and cloud approach by using the same APIs in the cloud and the same asset models that you have modeled in the cloud at the edge. And with that, we come to the end of this presentation. Thank you very much for joining us, and hope you can have fun with the service. Thank you.